Here we are, we're doing more circuits problems, and we're looking at number 9. And let's take a look at how to solve the circuit. This is the first time we've seen this weird circuit where you have two batteries. You got one battery where positive is here, it's to the left, and negative is on the right, on the 20 volt. And the 2 volt is actually going the other way. And so that means if you were to go up 20, and then come here, you'd go down 2. So it's actually, if we think about this circuit, it's the same as having an 18 volt battery. So this is a fairly easy version of when you have two batteries. It can definitely be more difficult than this. But anyway, we can just replace it with an 18 volt battery going the direction of the 20 volt battery. Also, we have this 12 ohm and 6 ohm that we can treat as parallel resistors and replace them with a 4 ohm resistor, doing a little math there. And I like to call it crazy add because a 12 and a 6 turn into a 4, which makes sense because there's two pathways, makes it easier for current to flow. And once we have this circuit, it's pretty easy to solve it. We could see that if we have 2 amps, which they told us, we have 2 amps going through 4 ohms, we know that's going to be 8 volts. So that means that we must have a 10 volt drop on this resistor. And that means that this resistor with 2 amps and 10 volt drop must have a resistance of 5 ohms, since we have V equals IR, and 2 times 5 will give us our 10. So we know that the resistance for R is going to be 5 ohms. Now we also know that the 2 amps is going to split when it comes through this parallel section. And since we know that we have 8 volt drop on each of them separately, because if you do this loop, you need to have 8 volts. And if you do this other loop, you also would need 8 volt drop. And we know the ohms and the volts. We can divide to get the amps. And we get 1.33 and we get 0.66, which add up to 2. So that checks. So that's nice. So we now know the currents in both of those two. The reason I decided to do a screencast, that wasn't that tough, but it's interesting in this next section where they tell us that the voltage is 0 at this location that they're calling X. And so we're going to think about, as we flow with the current from 0 volts, where we go. So let's see what happens here. We're in a wire. There's no voltage drop in the wire because we're assuming the wire has no resistance. And now we're going to go down through a battery. So if we were at 0, we are now at -2. If the current, we're going with the current, and current goes down when it goes through resistors, this location being -2 volts, if we go this direction, we're going to drop another 8, we'll be at -10, so that makes sense. Notice if we went the other way, starting at 0, we would go down to -2, and go this direction, we would also drop down to -10. Now we're going to go up a 20 volt battery, so that brings us up to positive 10 volts. And then we're going to drop through this resistor back down to 0. So what's nice about this in pink, it shows how it's sort of arbitrary where the voltage is 0. And you'll notice if I was doing this and talking about it in class, I'd be more likely to have C be 0 volts, because I'd think about going up 20, down 10, down 2, and down 8 to get back to 0. But it's fine to have negative values for voltages. And we can go ahead and have 0 be at any place in the loop, as long as when we go through the loop, we get back to the same voltage again after going around the loop. So I hope that helped understand a little bit on this problem. I'd ask you to just do it again from scratch and try to understand it as best you can. It's a doozy. Anyway, thanks. Good luck.